Hello students, I Mahindra Thomre, Assistant Professor of Department of Chemistry, G Societies, M.B. Mehta, Science and Commerce College, Bordi. And I am teaching you a chemistry paper 3, that is the Organic Chemistry of m.sc Part 1, and this is our semester 1 of Part 1 lecture of Unit 2nd, that is Nucleophilic Substitution Reactions and Aromaticity. In this unit, we have to study now the new topic, that is the aromaticity. So, what is the aromaticity? What is means by aromaticity and different types of examples of aromaticity? Now we have to study. So, aroma. The name suggests the aroma means pleasant smelling compounds. So, aroma means pleasant smelling compound. The pleasant smelling compound which involve in electrophilic substitution reaction are known as aromatic compound. So जो भी pleasant smelling compounds that are in electrophilic substitution reaction are known as aromatic compound. The cyclic compounds are classified into three types. First one is the aromatic, second one is the anti-aromatic, and third one is the non-aromatic compounds. That is the aromaticity. So first one is the aromatic compound. So which are the conditions for aromatic compound? So molecule is cyclic and planar. The first criteria is molecule is cyclic and planar for aromatic compound. In cyclic molecule, every cyclic atom must be unhybridized orbital. साइक्लिक मॉलिक्यूल में सब एटम कैसे होने चाहिए? अनहाइब्रिडाइज्ड ऑर्बिटल्स. So here is the example I have given. So sideways overlap. Here is sideways overlap. This is the sideways overlap between benzene rings. Here also sideways overlap. These all are the sideways overlap of p orbitals. That is the formation of this benzene ring. So how the benzene ring formed? By sideways overlap. अनहाइब्रिड ऑर्बिटल अंडरगोज साइडवेज ओवरलैप. जो भी अनहाइब्रिड ऑर्बिटल्स है उसमें वो किसके? दैट इज गोइज अंडरगोज इन साइडवेज ओवरलैप. cyclic molecules consist of pi conjugation. So all cyclic molecules consist of at least consist of pi conjugation. conjugation में ही रहना चाहिए. That is first one is the cyclic and planar रहना चाहिए. Then unhybridized orbitals होने चाहिए cyclic molecules में. Unhybrid orbital undergoes sideways overlap, and then cyclic molecule consists of pi conjugation. During sideways overlap, continuous delocalization of pi electrons required. So sideways overlap के in sideways during sideways overlap continuous delocalization of pi electrons चाहिए हमको. So molecule accept 4n plus 2 pi electron rule, that is the Huckel rule. So Huckel said that the molecule which accept or obeys 4n plus 2 pi electrons rule system, that is the aromatic compound. So n is any integers 0 to etc. 1 2 3 4 5. So 4n plus 2, when we have taken n is equal to 0, 4 into 0 plus 2, that is the 2 pi electron. When n is equal to 1, it gives 6 pi electron. When n is equal to 2, then 10 pi, and 3 when then 14 pi electron system. So 2 6 10 14 8 14 ये जो भी है ये क्या है? जब ऐसे इलेक्ट्रॉन्स मिलेंगे हमको, when we have given the molecule is having a 2 6 10 14 pi electrons, then it follows the Huckel's rule. So as delocalization of molecule increases, stability also increases. So जैसे जैसे delocalization molecule का बढ़ेगा, so stability भी increase होती जाएगी. So aromaticity is directly proportional to the stability. Aromaticity is directly proportional to stability पर है. Stability जितनी होगी उतना aromatic compound होगा. So some examples of aromatic compound, that is the naphthalene, furan, indole, pyridine, tropylium ion, cyclopentadienyl anion, then cyclooctatetraene. ये example है, but it is the not aromatic because of it lost its planarity due to tub shaped molecules. So हम आगे ही देखेंगे वो. So that is the aromaticity is directly proportional to the stability, that is the aromatic compounds. So next one is the anti-aromatic compounds. So anti-aromatic compounds also possess some similar properties as the aromatic compound, that is molecule is cyclic and planar. Then in cyclic molecule every cyclic atom must be anhybridized orbital, that is sp2 or sp. Unhybrid orbital undergoes sideways overlap as is like aromatic compounds. During sideways overlap continuous delocalization of pi electrons required as like a aromatic compound. Then cyclic molecule consists of pi conjugation. It is also aromatic like aromatic molecule except 4n pi electron rule, that is the Huckel's rule. So here is in aromatic compound 4n plus 2 pi electron rule is there of Huckel's. Huckel says that when electrons carries 4n plus 2 pi electron, that is aromatic, but when contain 4n pi electron, that is the it is anti-aromatic compounds. So if n is equal to any integer, then take 0 over to 1, 1, 2, 3, 4, 5. When 4n is equal to n is equal to, when we consider 0, so 4n in 4n, 4 into 0 is equal to 0 pi electron. When n is equal to 1, 4 pi electron. When n is equal to 2, it gives 8 pi electron. So that when 0, 4, 8, 12, these are all when electrons are come in molecules, then that is the anti-aromatic. And when we possess these all conditions, cyclic planar, then sideways overlaps, that is the conjugation of electrons, so that is the aromatic compounds. So as delocalization of molecule increases, stability decreases, but in anti-aromatic compounds, when delocalization increases, the stability decreases. So anti-aromaticity is inversely proportional to the stability of compounds. So these are the examples of anti-aromaticity. So pyrazole, oxazole, isoxazole, thiazole, isothiazole, 1H indole, isoindole, 9H carbazole. These all are the anti-aromatic compounds. So third one is the non-aromatic molecules. So which are the non-aromatic molecule and which are the conditions for non-aromatic? The molecule is not aromatic and not anti-aromatic. So for non-aromaticity, the molecule is not aromatic as well as not anti-aromatic. So दोनों भी नहीं होने चाहिए, aromatic भी और non anti-aromatic भी. The molecule is may be cyclic or non-cyclic, planar or non-planar. It depends on molecule. So my cyclic भी चल सकता है, non-cyclic, planar और non-planar भी चल सकता है. So cyclic atoms may be sp, sp2, sp3 atoms, where cyclic atoms may or may not have anhybrid orbital. So anhybrid orbital may or may not, मतलब होने भी चाहिए या अपनी नहीं भी हुए तो भी चलता है in non-aromatic compound. They accept 4n plus 2 pi and 4n pi electrons. They accept both means 4n plus 2 pi and 4n pi electron, both rules they are accepted. Molecule may not have conjugation or having conjugation, that means conjugation is possible or not possible also they in non-aromatic. Stability of molecule are intermediate between aromatic and anti-aromatic molecule. So इसकी stability किस पर है, intermediate है दोनों में, aromatic और anti-aromatic के बीच में की है, that is the non-aromatic. So stability is first one is the aromatic, then non-aromatic, and then less stable anti-aromatic. So this is the stability of aromatic, non-aromatic and anti-aromatic. So homoaromaticity. So this, what is the homoaromaticity? The cyclic molecule having sp3 atom or carbon with similar stability as that of aromatic compounds. So कोई भी cyclic molecule sp3 atom और carbon with similar stability as that of aromatic compounds के जैसे ही stability होनी चाहिए उसको. But the cyclic molecule having sp3 atom, मतलब कोई भी carbon CH3, कोई भी CH2 CH3, कोई भी एक cyclic molecule में sp3 atom होना चाहिए और उसके बाकी के कार्बन्स की सिमिलर स्टेबिलिटी एज दैट ऑफ एरोमेटिक कंपाउंड्स की होनी चाहिए. The cyclic molecules having continuous pi delocalization by passing sp3 atom are known as homoaromatic compound. The cyclic molecule having continuous pi delocalization, pi delocalization continuous हो रहा है, but by passing one sp3 का atom, मतलब कोई भी एक कार्बन एटम हम उसको उसको कंसिडर करेंगे नहीं और डायरेक्टली उसका कंटिन्यूस pi delocalization मतलब रेजोनेंस करेंगे. Every homoaromatic molecule are aromatic, but every aromatic molecules are not homoaromatic. मतलब जितने भी homoaromatic molecules है, these all are the aromatic है. But every aromatic molecules are not homoaromatic. Means सभी aromatic compounds are not homoaromatic. But जितने भी homoaromatic compounds है, वो सभी aromatic है. So this is the example of this homoconjugation linkage insertion. So here one carbon is there where there is no positive matlab there is no double bond, that is sp3 atom. So one atom is here, that is this is the sp3 carbon. So by passing this sp3 there is resonance here, here is resonance by passing sp3 atom. So that is the homoaromaticity. So these all are the aromaticity, basic concept of aromaticity, anti-aromaticity, and non-aromatic compounds and homoaromaticity. So next one is the our question: why aromatic compound does not undergo addition reactions? So first compound, that is benzene, is aromatic because it is having conjugation and obeys 4n plus 2 pi electron system. When reaction with AB, it gives A here and B here, addition reactions. So एडिशन रिएक्शन की वजह से यहाँ पर क्या हो रहा है, ये नॉन एरोमेटिक में जा रहा है. क्यों? क्योंकि इट डज नॉट ओबे 4n plus 2 pi electron system or 4n system and lost its planarity due to addition of this A and B. So that is why aromatic compound does not undergo addition. When aromatic compound undergoes addition reaction, it becomes non-aromatic compound, that is loss of aromatic characters, and no addition reaction for aromatic compound, but they do undergo aromatic electrophilic substitution reaction because aromatic character is retained after completion of reaction. So क्या हो रहा है यहाँ पर, इलेक्ट्रोफिलिक सब्स्टिट्यूशन हो रही है. क्योंकि इलेक्ट्रोफिलिक सब्स्टिट्यूशन की वजह से कुछ भी उसमें अनस्टेबिलिटी हो फॉर्म नहीं हो रही, और रिटेन कर रहा है अपनी कैरेक्टर, एरोमेटिक कैरेक्टर्स. So when aromatic compounds are placed in external magnetic field, they generates diamagnetic ring. So aromatic compounds क्या फॉर्म करेंगे, मैग्नेटिक एक्सटर्नल मैग्नेटिक फील्ड उसमें प्लेस करेंगे तो डायमैग्नेटिक रिंग, and therefore called diatropic compounds. But when anti-aromatic compounds are placed in external magnetic field, they generates paramagnetic ring current. So पैरामैग्नेटिक फॉर्म करेंगे जब एंटी एरोमेटिक हम उसको प्लेस करेंगे एक्सटर्नल मैग्नेटिक फील्ड के साथ. सो एंड देयरफॉर कॉल्ड एज पैराट्रोपिक कंपाउंड्स. सो क्राइटेरिया फॉर एरोमेटिसिटी जो हमने अभी देखा, बेसिक क्राइटेरिया, दैट इज द एरोमेटिक एंड एंटी एरोमेटिक कंपाउंड्स में. सो साइक्लिक मॉलिक्यूल क्या होना चाहिए, साइक्लिक, एरोमेटिक में भी एंटी एरोमेटिक में भी. प्लेनर, both have one, both having planar, fully conjugated, both are fully conjugated. But here aromatic is 4n plus 2 pi electron system, it obeys, and here 4n pi electron system. N is equal to integer 0 1 2 3, where n is equal to 1 2 3. So pi electrons are 2 6 10 14, here is 4 8 12 16, and this after 16 20. So in aromatic compounds, all electrons enters in highly stable bonding molecule orbital. Moreover, all BMOs are completely filled, therefore they are highly stable. So aromatic compounds में bonding molecular orbitals completely filled होते हैं, so they are highly stable. So in anti-aromatic compounds, electrons enters in highly energetic anti-bonding molecular orbitals. Highly unstable होते हैं फिर. So anti-aromatic में क्या होता है? Anti molecular orbital, anti bonding molecular orbital highly unstable होते हैं and remains unpaired, therefore anti aromatic compounds are highly unstable. रो unpaired भी होते हैं, so that is why they are highly unstable. Resonance energy of aromatic compound is very high, which is also increases stability. So resonance energy की वजह से भी aromatic compounds की stability बढ़ रही है, and this is due to fully conjugated electrons. So we have taken 6 electrons, that is in bonding. Here is 1, 2, 3, 4, and this is 5, 6. So all are in bonding molecular orbitals. So this is and in between this is energy barrier. So ये stable होता है, सभी उसके bonding में ही हो रहे. Here also instability because of ये पूरे के पूरे बॉन्डिंग में अनपेड रह रहे, एक एक इलेक्ट्रॉन उसका अनपेड रह रहा है बिकॉज ऑफ हंड्स रूल. We have taken a cyclopropane and related compound. Cyclopropane is, there is non-aromatic compound. Here is cyclopropene. It is also non-aromatic compound because 2 electrons and there is no conjugation. Here is cyclopropenyl cation, that is the aromatic compounds. Why? Because of conjugation, that is this double bond is goes here and this positive charge is stabilized. So this is the resonance, and also it aromatic compounds, aromatic criteria also, 4n plus 2 pi electron also follows. Cyclopropenyl cation is highly stable. Explain or why cyclopropenyl cation is aromatic. So it is a cyclic, जो मैंने अभी बताया आपको. Then it is planar. Then it is fully conjugated, means cyclic, planar, then fully conjugated, and contains 4n plus 2 pi electron, that is the 2 pi electrons. Here is 2 pi electrons, so this bond is having a 2 pi electrons, 2 pi. Therefore it is aromatic. Aromatic compounds are highly stable. This is due to high resonance energy and completely bonding molecular orbitals. So resonating structure ये ऐसे हम लिख सकते हैं इसका. Here this double bond goes here, so here is positive charge, so it also here, now the positive charge is here. So resonance hybrid, this is the structure of resonance hybrid, means resonance हो रहा है दो तीनों पर जगह कार्बन पर पॉजिटिव चार्ज घूम रहा है. The cyclopropyl anion is highly unstable. Explain or why cyclopropyl anion is anti-aromatic. So cyclopropyl anion is also cyclic, planar, conjugated also is there because negative charge is there. So negative charge उसका resonance करेगा. But it क्या contains 4n pi electron system. मतलब ये टू नेगेटिव के और ये टू, that is the 4 electron. So it follows the anti-aromaticity. So दोनों में भी सेम है, बट यहाँ पर 2 electrons नेगेटिव चार्ज की वजह से इंक्रीज हो रही है. So it goes in anti-aromatic compounds. So here is the resonance for cyclopropyl anion. So cyclopentadiene and related compounds. So cyclopentadiene is non-aromatic. Why? It is not having a conjugation, that is no positive or negative charge here. It is having positive charge but only 4 pi electrons, so it is anti-aromatic. And it is having negative charge and it is having a 6 pi electron system, that is why it is aromatic. So it is aromatic compound. When cyclopentadiene anion is highly stable, or why cyclopentadiene anion is aromatic. तो रेजोनेंस कैसे दिखाएंगे साइक्लोपेंटाडाइन आयनाइन का? ऐसे रेजोनेंस दिखाएंगे हम. तो रेजोनेंस हाइब्रिड मतलब साइक्लोपेंटाडाइनिल आयनाइन क्या है, यहाँ पर स्टेबल हो रहा है. सो व्हाई साइक्लोपेंटाडाइनिल कैटायन इज हाईली अनस्टेबल. कैटायन मतलब यहाँ पर भी रेजोनेंस हो रहा है, बट प्रॉब्लम क्या है, यहाँ पर there is only 4 pi electron system, that is why it is anti-aromatic. So it is unstable. So cycloheptatrine and related compounds. So cycloheptatrine is non-aromatic because 6 pi electron system, but it is not having a conjugation. That is, this carbon is remaining. Tropylium ion or cycloheptatriene carbocation, ये क्या है, एरोमेटिक है. क्यों? यहाँ पर इज हाईली स्टेबल. क्यों? प्लेनर है, साइक्लिक है, फुल्ली कॉन्जुगेटेड है, देन कंटेन्स 4n plus 2 pi इलेक्ट्रॉन सिस्टम, देयरफॉर इट इज एरोमेटिक. तो ये यहाँ पर ऐसे रेजोनेंस दिखा रहा है. So this is the resonance of cycloheptatriene cation. When cycloheptatriene anion is highly unstable or anti-aromatic, तो ये साइक्लिक है, प्लेनर है, फुल्ली कॉन्जुगेटेड है, but contains 4n pi electron system, so it is anti-aromatic. So resonance also there, cyclic, planar, fully और conjugated सभी है इसमें, but because of 4 pi electron.
So here is the 12, 14, 16, 18 annulines. So we have taken a first 12 annulin. That is the first example is 12 annulin. So transannular interaction, 12 annulin क्यों कहते हैं इसको? 12 carbons is there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So that is why 12 annulin. So here is a transannular interaction of these hydrogens. So this is, ये क्या करेगा, नॉन प्लेनर कंपाउंड फॉर्म करेगा. दैट इज व्हाई इट गिव्स द नॉन प्लेनरिटी. तो प्लेनरिटी लॉस होने की वजह से इट इज नॉन एरोमेटिक कंपाउंड. देन 14 एनिलिन. सो 14 एनिलिन में क्या है, सेम यहाँ पर भी ट्रांसएनुलर इंटरेक्शन इज देयर. सो इट इज आल्सो नॉन प्लेनर, दैट इज व्हाई नॉन एरोमेटिक कंपाउंड. देन 16 एनिलिन. सो इन 16 एनिलिन इनर कैविटी इज मोर. सो इनर कैविटी मोर होने की वजह से यहाँ पर के हाइड्रोजन्स आर फार अवे फ्रॉम ईच अदर. सो यहाँ पर ट्रांसएन्युलर इंटरेक्शन नहीं होने वाला, नो ट्रांसएन्युलर इंटरेक्शन. सो ये इसकी प्लैनेटरी लॉस नहीं हो रही है. सो अकॉर्डिंग टू दिस ये क्या है, एंटी एरोमेटिसिटी फॉलो कर रहा है. इलेक्ट्रॉन 4n पाई इलेक्ट्रॉन सिस्टम फॉलो कर रहा है. नाउ द 18 एनुलिन. So 18 annulin is aromatic. Why? Because inner cavity is more, so hydrogens are far away from each other. Hence no transannular interaction. So planar and aromatic compound. ये far away है, हाइड्रोजन जो अंदर है वो उसके कैविटी, इनर कैविटी मोर है उसकी, सो वो प्लेनरिटी लॉस नहीं कर रहा है और एरोमेटिसिटी भी फॉलो कर रहा है. तो दैट इज वाई हाईली स्टेबल भी है, सो वो एरोमेटिक कंपाउंड है. Just we have take a question, which of the following is more stable and why? So 14 annulin, so both are 14 annulins, but structure are different. So here is this hydrogen is there here and here, but here both hydrogens are inner side. So due to this there is transannular interaction in this, so it is less stable. But here only 2 hydrogens, so there is no transannular interaction, so it is stable and it follows the aromatic compound, it is 4n plus 2 pi electron system. मीन्स होमोएरोमेटिसिटी। तो होमोएरोमेटिक कंपाउंड क्या है, जो हमने पहले भी अभी इसी लेक्चर में स्टार्टिंग में देखा है। तो वो बाय अवॉइडिंग वन sp3 कार्बन वी वी रेजोनेट वी मतलब हम रेजोनेंस कर सकते हैं एक इलेक्ट्रॉन्स, ये sp3 जैसे यहाँ पर एक sp3 छोड़कर हम यहाँ पर एक sp3 छोड़कर हम यहाँ पर रेजोनेंस कर सकते हैं। वैसे ही उनको क्या कहते हैं, होमो एरोमेटिक कंपाउंड। तो जस्ट आई एम हियर गिविंग यू द स्ट्रक्चर ऑफ होमो एरोमेटिक कंपाउंड। सो एक sp3 कार्बन, मतलब ये यहाँ पर का sp3 ऊपर वाला कार्बन अवॉइड करते हैं तो ये यहाँ पर रेजोनेंस हाइब्रिड मिलता है यहाँ से, दैट इज द 6 इलेक्ट्रॉन्स। So benzenoid compounds. So benzenoid compounds कौन से? These are the compounds having one or more benzene or benzene-like rings. Hackett rule is applied to benzenoid compound as follows. So number of conjugated double bonds कितने हैं benzene के? 1, 2 and 3. So 3 into 2. So number of conjugated pi electron कितने होगी फिर? 3 into 2 6. So according to Hackett's rule 4n plus 2 gives 6 electrons and when n is equal to 1, जब n मतलब एक रिंग है तो n is equal to 1, so benzene satisfies Hackett's rule for n is equal to 1 as it is aromatic. Then naphthalene, number of conjugated double bonds are 5. So conjugated pi electrons कितने हैं? 5 into 2 10. So according to Hackett's rule 4n plus 2 also gives 10 electron जब हमने n is equal to 2 लिया, 2 rings in naphthalene. So same number of conjugated and Hackett's rule के हिसाब से 10 electrons. So it follows satisfies naphthalene satisfies Hackett's rule for n is equal to 2, hence it is aromatic. Then anthracene, number of conjugated double bonds are 7 and number of conjugated pi electrons are 2, 7 into 2 14. So Hackett's rule के हिसाब से भी n is equal to हम एंथ्रासिन में 3 लेंगे, 3 रिंग्स के, तो 4 into 3 for 12 plus 2 that is 14. So it matches the 14 that is conjugated double bonds pi electrons and Hackett's rule. So the anthracene is also aromatic compound. So non-benzenoid compounds. So these compounds have unsaturated ring system and not resembling benzene ring. Unsaturated ring होनी चाहिए but benzene के जैसे सिमिलर सिस्टम नहीं होनी चाहिए. So cyclopropane. So cyclopropane and cyclopropynyl cation. So cyclopropane में कितने 2 इलेक्ट्रॉन्स हैं और cyclopropynyl cation में कितने इलेक्ट्रॉन्स हैं? 2 इलेक्ट्रॉन्स हैं. So both are the aromatic होने चाहिए but because of here loss of conjugation or and here there is conjugation because of positive charge. So हमने conjugation पहले भी देखा है इसमें. So ऐसे conjugation होगा तो positive charge is तीनों कार्बन्स में जाएगा. So that is why cyclopropynyl cation is aromatic and cyclopropane is non-aromatic. Then cyclopentadiene and cyclopentadiene is anion. So cyclopentadiene and is having a 4 electrons and cyclopentadiene anion is also 6 electrons. There is 6 electrons. So it follows the aromatic compound because here is conjugation. There is conjugation is there in cyclopentadiene anion. So that is why cyclopentadiene anion is conjugated. Cyclopentadiene only diene is non-aromatic. So difference between, in short, we have taken difference between aromatic, anti-aromatic and non-aromatic compounds. So aromatic is usually stable but anti-aromatic usually unusually unstable होते हैं. So both are cyclic, both are conjugated. But here aromatic is 4n plus 2 pi electron system, and here for anti-aromatic 4n pi electron system. Both are flat, means planar. The example of this is benzene. An example of anti-aromaticity is cyclobutadiene. इन चारों में से एक भी अगर from this fails any one criteria, so it will goes in non-aromatic compounds. The example of non-aromatic compound are cyclooctatetrene. So adapt a tub-like shape to escape anti-aromaticity. मतलब anti-aromaticity फोरियन सिस्टम फॉलो कर रहा है, बट ड्यू टू द टब शेप मॉलिक्यूल, मतलब इसका टब शेप में कन्वर्जन होता है. सो ये टब शेप मतलब ये कैसे, एज लाइक अ डब्ल्यू. तो ये क्या होगा, एज लाइक ए डब्ल्यू, ये टब शेप होगा उसका फॉर्मेशन. तो टब शेप होने की वजह से ये क्या हो रहा है, इसकी प्लेनरिटी लॉस कर रही है. दैट इज व्हाई इट इज नॉन एरोमेटिक. cyclooctatetrene is non aromatic. So thank you students, here we have completed our major topics of aromaticity.